Okay, so we're going to have a look at histograms. And histograms are a type of diagram. It's how we display different information, and it's how we display what we talk about as continuous data. Okay, so continuous data are things like height, weight, time, different things like that. Okay, and they're continuous. Because if you imagine, if I was in the classroom and I measured everyone's heights, okay, you'd probably give me the height more or less closest to the nearest centimetre. Okay, but actually, if we looked at it even more accurately, we'd probably find that we could get it to 0.5 or even 0.43, who knows. But the point is all of the values can be continuous, okay, and that's why we use histograms. Now, histograms look a little bit like a bar chart, okay, in the fact that they have bars. But if you imagine, if we've got a bar chart, they have equal bars. Oh, that one's not great. With equal widths between them, okay? But because a histogram is continuous, actually we don't have this equal gap between them. And in fact, we have no gaps between them, okay? We have a continuous stream from one to the other. So if we have a look at a histogram, here's one I prepared earlier, you can see that this is what it looks like, okay? The bars are all different widths. Some are quite narrow, some are much wider, some are taller. They're a mix, okay? They're a mix of different bars. Along the side, or up the side, we always have our frequency density. So our y-axis, as you think about it, is always frequency density. And then whatever continuous thing we're looking at is time. In this case, is time, goes along the bottom. And you can see they just go up in stages. So if I was looking at seconds, 10 seconds, 20, and so on, okay? And this is a histogram. Okay, so what we can say is there are no gaps between the bars. The only time a gap will occur is if something's zero. Okay, so if you imagine if this was 0, then yeah, there would be a gap because it's 0. And the other thing is they are not equal widths. Okay, now what we can do with histograms is we can work out a few different things. So if we have a look at the most important things to do with histograms, we've got these three things here. We've got frequency, frequency density, and class width. So if we have a look at class width first, okay, this is basically, okay, the difference between the upper and lower bound. Okay, so what I mean by that is something like this. 0 is less than t is less than or equal to 10. Okay, that is my class. That tells me that we're looking at the values between 0 and 10. To find my class width, I literally do 10 take away 0, and I would get 10. Okay, if I look at another one, if I had something like 35 is less than t is less than or equal to 40, then I would just do 40, take away 35, and my class width would be 5. Okay, and that is how I find out my class width. Now, it's important to notice that with all of these, one of your values will have this inequality sign, the other one will have that, and the inequality signs will always face the same way. So why I've written these three, you might spot, they form a bit of a triangle. Okay, they form a bit of a triangle between the three of them, and that is because these three things allow us to use them for histograms and work out everything we need to work out. Frequency is as it is, it's the total. Frequency density is basically how dense your frequency is, and that's what we look at with our histograms. Okay, so if we have a think about these three, to find frequency, I'll cover it up. I'm just, oh, you can't see if I do it that way. I'm doing frequency density times by class width. To find frequency density, I'm just doing frequency divided by class width. And to find class width, I would do frequency divided by frequency density. And as long as I know these three, I can do a lot of work with histograms. Now, if we go back to this one that we drew a few minutes ago, okay, and we look at this top one, frequency is frequency density times class width. Okay, so I'm just going to write it down here. So frequency equals frequency density times by class width. Or we sometimes talk about the area of the bar, because that's basically the same thing. Okay, if you imagine if I look at this bar, my class width is there, my frequency density is there. So if I times the two together, I'm going to find out what my total frequency is. Okay, so if I look at this one, my class width is 10. My frequency density is 0.5. So I would just do 10 times 0.5 and my frequency is 5. If I have a look at the one next to it, again, we've got a frequency density of 1, a class width of 20. So I'm just going to do 1 times 20, which is 20. Okay, and that gives me my different frequencies, and that is one way you can do it. So when you get questions about histograms, sometimes you'll be asked to draw the histogram. Sometimes you'll be given a histogram and actually asked to work backwards. And so what we're going to do now is look at a few of these. Okay, we'll look at what happens when you get a bit of a mix in a table. So you get something like this, okay, where it's given you some frequencies, some frequency densities. It's given you your classes, and you've got to try and work everything out. So first thing to do, I'm just going to write down my little triangle. So I've got my F, FD and CW, just so I can remember what I'm doing. Now what I quite like to do with this is always write down what my class width is. Okay, so in the first case it's going to be 10, then I'm going from 10 to 15, so it's going to be 5. 15 to 35 is going to be 20, and 35 to 45 is going to be 10. Okay, and then I just have to follow through the process. So to find my frequency density, I'm doing frequency divided by class width. So I'm going to do 40 divided by 10, which just gives me 4. To find my frequency again, our frequency density, we're doing frequency divided by class width. So I'm doing 6 divided by 5 to get 1.2. Do not worry, with histograms, you are likely to get decimals. Okay, don't panic. Frequency density is more than normally decimals. It's weird when it's all whole numbers, okay? It does happen some of the time, but generally they will be decimal numbers. Then if I want to work back to my frequency, okay, I'm doing my class width times my frequency density. So I'm going to do 2.6 times by 20, which is going to give me 52. And then I'm going to do 1 times 10. Again, doing frequency density times class width to get 10. And I have now got a completed table. I know all my frequencies, I know all my frequency densities. Now, why this would be useful is likely a question like this. They would have drawn part of the histogram. They might just want you to fill in the table. Or what they might have done is given you half of a histogram. Okay, so you might have had part of it, and actually they want you to fill in the rest of it. Okay, so this sometimes happens where they give you part of your histogram drawn. So they might give you the first bit, first bar, and then they'll have a gap. Something like this, for example. They'll give you something like that, and they'll want you to draw this bit. Okay, they'll want you to use the information to try and draw the extra bits. You might have to use the different frequency densities that you've got to work out where exactly it goes. Okay, hopefully that at least gives you a bit of an overview. The really important things are knowing those formulas, okay, are knowing what to do with those calculations. So that triangle that I said about where we've got frequency, we've got frequency density, and we've got class width. That is probably the most important thing, okay? Knowing that your frequency is equal to your frequency density times by your class width, that your frequency density is your frequency over your class width. And as I say, we don't use this one quite as much, but class width is frequency over frequency density. And the other thing to remember with this is the same thing as the area of the bar. If you can get those things, oh sorry, you can't see this. I've just written it all there, sorry, and now you can't see it. Frequency over frequency density, that's what I've written there. And that is the area of the bar. If you can get these things written down, understood, then you will be able to do this. If you keep going back to this, you'll be able to do it. Okay, keep up the good work. Bye.